Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is an introduction to networking and to the networking models video. We're not going to have a great deal of live labs in this particular course. I have developed quite a few illustrated examples for you, but it is difficult, if not impossible, to show you everything you need to know about the networking models and TCP and UDP by working just on the routers and switches. So I've got plenty of illustrations here, going to keep it as lively as I can, but as you'll see, there's a lot of information here, a lot of theory, and I will reiterate this during the video. It's theory you need to know, not just for the exam, but for the real world. And I'm going to show you why as we go through this, because that tends to be the number one question when someone's slogging through the models and the data transmission process. Like, do I really need to know this stuff? Here's my answer as a veteran of the field. Yes, you do. It will help you greatly, not only to nail the exam, but really accelerate your career and your troubleshooting skills, which is really where the line gets drawn between okay network admins and great network admins, which is where you want to be. We're going to start off with a quick discussion of what a network is to begin with. And we talk about it all the time, but what is it? Why does it seem so complicated? How can we make it easier? And we're going to use a couple of models to illustrate how networks operate. And the first will be the OSI model, the second the TCP/IP model, and we'll also in the middle there discuss how the data gets broken down from the time the end user inputs data to the time where the data has to take the form of ones and zeros. It's got to go across a cable sooner or later. It's got to be put into the physical layer format of bits, and bits are ones and zeros. That's it. Then we're going to answer the musical question, why use networking models? And it is a question that everyone asks at this point in their studies when they start going through it. So I'm going to answer that for you. We're going to go into a very detailed discussion of TCP and UDP, and I almost put TCP versus UDP here because while they're not really fighting with each other, the exams put a premium on knowing the differences between the two. That's where we're going to focus as well because frankly there aren't a lot of similarities. They're mostly differences. Then we'll discuss ports, sockets, and port numbers. And if you don't know what any of those are, that's perfectly fine. That's why we have the video here. And we're going to discuss why ports are used, what a socket is to begin with. It sounds like hardware, right? You know, it sounds like something we would install on a PC, but it's not. We're going to see what it is. And then we'll discuss some well-known port numbers that you definitely need to know for the exam and that will come in handy on the job as well. So before we get to all that, let's just take a look at what a network is to begin with. When it comes to learning anything in networking or with computers or really anything, I don't care what it is, the real key is to take a complex subject and break it down into the smallest piece, learn it part by part, keep building on that, and before you know it, you're an expert. You're where you need to be. And when you break networking down into the simplest concept possible, this is really what we have. We need to get data from one point to another in the most effective manner possible. Hey, that's it. Okay, class is over. Thanks for buying the video. Well, it's not quite that simple. It does get a little more complicated, but really this is what we're trying to do. We're just trying to get data from one point to another in the most effective manner possible. It sounds pretty simple, right? And a lot of the time it is fairly simple because after all, I mean, what is a network? We've got a couple of PCs, right? We got a couple of hosts. We'll just use 3 in this particular example. Well, they need to be able to talk to each other. So we better connect them with something. Now, in the bad old days, it would have been, you know, one piece of cable, and then we would have had to work with all kinds of coax cable. We really don't have that anymore. What we generally have are our hosts connected to a switch. And as I'll mention throughout the course, you're responsible for being able to look at that drawing on an exam or an exhibit question and say, okay, I know this is a switch, so this is going to happen and this is going to happen. So again, if you don't know that, you will by the end of the course. But we're going to connect our host to a switch. And you know, one thing I've noticed about end users and our hosts, I'm not speaking badly of them, but they always want something, right? So they're probably going to want to be able to say print. So we're going to put a print server on the network. And let's see, we're going to need an email server, and those PCs are going to want internet access, and they're going to want connectivity to other networks in the company, which means we're going to need a router, and we're going to need an e-commerce server because we're going to stay in business. We got to make money. We got to have an e-commerce server. Well, you get the point by now. We build networks such as this, and we keep tacking on to it, right? And all of a sudden, we've got an e-commerce server and a print server and an email server and internet access. And on the other side of that router, if you will, going out to the net, we may have a wide area network. We've probably got other small offices in our company that need to communicate with each other. So we build networks like that to allow devices, such as the ones you saw in that exhibit, to communicate with each other. And what tends to happen is that you start off fairly small and you just keep adding to it. And that can be a real challenge because we have to remember not all of us have unlimited budgets. Matter of fact, these days, very few of us have unlimited IT budgets. So if you want to put something brand new on your network, and you go to your manager or whoever's signing the checks and you say, hey, by the way, we need to update and get the latest and the greatest of everything else we've got too so they can work together, you know, the boss, she's going to say no. She's probably going to say no. You got to make it work with what you've got. And that's a challenge. And as different devices are added to the network, that communication between devices becomes more challenging to allow. And we have to keep in mind, it's not just allowing communication in our network that's challenging. There are communications that we do not want to allow as well. Say our e-commerce server. Maybe we don't want every host in the network to have connectivity to that server. Maybe, frankly, we don't want some of the hosts to even know that it exists. And we can do that. And as you'll see in your further studies, in your intermediate and advanced studies, it's not that hard in many cases to just really hide a device. If you've got a server that only 2 hosts need access to, we can do that. But we have to keep in mind, again, with our networks that it's not just allowing every host and every server on the network to communicate. It's allowing a lack of communication, if you will, or to block communications between certain devices. And we also have to be wary of intruder attacks, right? There are all kinds of bad guys who want to get into your network. And we've got to keep them out. We're going to talk about that in a separate video, but that's our challenge of networking. We're going to keep tacking on these devices, and some of them may be 6 months old, some of them may be 6 years old, but you got to make them work together. And then you're going to have other hosts on the network, and you don't want them to see other devices. You don't want them to know you've got an e-commerce server. And then we've got intruders, and we got to keep those guys out. So that's our challenge. And the thought of learning all of this, I'm going to tell you, and again, this is from experience because I want to remind you, I was not born with the knowledge I have of computers and networking. None of us are, but let's be frank, some of us act that way, right? I've been exactly where you are. You may be advanced as compared to where I was at one point with your studies because we all start somewhere. And I'm telling you from experience, having worked my way from an entry-level certification all the way up to the top of the certification ladder, if you will, the CCIE, and I've taught thousands of CCNAs and CCNPs worldwide. And I can tell you, the key to networking success in both the exam room and working with real-world networks can be summed up in 5 words. Know and understand the fundamentals. That seems really simple, right? It seems almost like a trite answer or a cliche. Well, you got to know the fundamentals. You'd be surprised how many people don't. There's nothing fancy here. Learning and understanding the fundamentals of networking, that's what this course is really all about. I want you to get CCENT certified. I want you to go on and have a fantastic career. I want you to go forward and get the CCNA, the CCNP, the CCIE. And hey, I'm not against other vendors. You want to go out to Juniper, you want to go out to Microsoft, CompTIA, and earn those top certifications. I want you to do that. But to earn those intermediate and advanced certifications and to master today's networks, you've got to master the fundamentals, because if you don't understand how networks operate, you can't fix them. And that's mostly what we do in our job. We do installation as network admins. We're going to do installations, and we're going to do some fine-tuning here and there, but a lot of us troubleshoot all day long. Now, in this particular section of the course, We're going to start with the most fundamental of all fundamentals, the OSI and TCP/IP networking models. And again, I want to tell you from experience, and I'll mention it again, this is not just stuff to memorize for the exam, okay? If you've ever taken any of my courses before or read any of my books, you know I pride myself on being very honest with you about some of this stuff when it comes to, hey, you have to know this. It's not exciting, but you got to know it. But I'm telling you, when it comes to the networking models, you're going to be surprised at how well they will serve you in the future when you know what's going on at each layer. It could be a little tricky at first. There's a lot of information here, but just take your time with it. You'll learn it, you'll understand it, and I'm telling you, I've been doing this for a long time when it comes to instruction and field work. I've done really all of it. And I'm telling you, to this day, I use the networking models for my troubleshooting approach every single time. Why are these models so important to begin with? Why are we leading off with this? Why do we care about the OSI and the TCP/IP networking models? And a common question, and one frankly that I had when I first started studying, and I'm not going to mention the vendor, but the book that I had to learn networking models from was just a nightmare. It was terrible. You're going to be very glad you bought this course, especially if I showed you that book. But the question is, beyond passing the exam, why do I have to learn this? Does it really matter? Do I really need to know it? And again, I'm going to tell you, having been exactly where you are right now, getting started with your studies, I had that thought more than once. It's like, okay, I'll memorize these layers, and I'll memorize what they do, and I'll never use this again. Actually, you will. You will. It's not as exciting as configuring routing and switches, but to know what's going on with the routers and switches, you need to know this material. And again, I'm just going to hit this one more time, and then we're going to move forward. It's not just something you need to learn to pass the exams. You will really find these models, whichever one you choose. I personally use the OSI model when it comes to troubleshooting, and I'm going to talk about that throughout the course, especially in the troubleshooting video. But using the OSI model as an orderly approach to troubleshooting is invaluable. It really is useful information. It is definitely not something that you just need to memorize. Now we're going to step into the OSI model first. We're going to take a look at the Open System Interconnection Networking model. Then we're going to compare it to the TCP/IP model. And after that, we're going to go into a fairly lengthy discussion of the differences and the similarities between TCP and UDP. I would strongly urge you to know all of these differences and the material in this particular video before you take your CCENT or your CCNA exam. Because, everything we go over in this course is important, but entry-level exams really like to focus on the material we're going to talk about here. So let's get started and take a look at the OSI networking model. And here is our new best friend, maybe an old best friend to you. You're probably familiar with this, but if you're not, certainly no problem there. This is the OSI networking model. And as network administrators, you and I are going to be primarily concerned with the bottom three layers: physical, data link, and network. That's where we're going to do almost all of our troubleshooting, all of our configuration on routers and switches. But for the exams, we got to be concerned with all 7 layers. We're going to take a look at what happens at each layer, then talk about the gradual process of taking that data that end users put into the network and changing that data into an electric signal that can be transmitted across a physical cable. Because something's got to happen between the end user and that cable, right? I mean, sooner or later, and I'm going to come back to this time and time again, it's all ones and zeros. Everything we do in networking sooner or later gets turned into a 1 or a 0, and that's the physical layer. So when even you and I as end users, we're sitting there typing something into Word, or we're using Telnet, something like that, everything we put in has got to be turned into ones and zeros, and it doesn't just happen at one time. There's a plan here. There are some steps here that are going to be followed as data goes down the OSI model. We're going to look at that, and also I want to mention now, the OSI layers are often referred to by number rather than layers. And the application layer is layer 7 or L7, the presentation layer is layer 6, and so forth, all the way down to layer 1, the physical layer. So to get you used to that, I'm going to refer to the layers by their names and their numbers throughout the course, and you should be comfortable with having it expressed either way on exam day. Now the application layer, this is the layer where the end users themselves are actually interacting with the network. Very important distinction here between authentication and encryption. When a user is being authenticated, that's happening at layer 7 of the OSI model. Encryption runs at layer 6, the presentation layer. The application layer has a couple of other jobs. First, it's going to ensure that the remote communication partner is available to begin with, and that the needed communication resources exist. If a modem is going to be used, the application layer is basically saying, is that modem ready? And the application layer also ensures that both ends of the communication are going to agree on procedures involving data integrity, privacy, and error recovery. Now, if you're trying to decide, say on an exam day or a job interview or whatever circumstance you're in, if you're trying to decide if a protocol is an application layer protocol, it's kind of slipping your mind a little bit, just remember that anything that requires the end user to enter a request, that's an application layer protocol. Firewalls also are considered to run at layer 7, and that is a device intended to keep network intruders out, among other things. Firewalls are getting more and more complex and offer more and more features. We'll talk a little bit about firewalls in the security section. But hopefully if you're on any kind of home internet connection, you're familiar with firewalls and you have one. Now protocols and services that run at layer 7, good list to know, are email protocols, simple mail transfer protocol, SMTP, and POP3, Post Office Protocol 3. Those run at layer 7. Telnet, which we're going to be using a great deal in this course, also runs at layer 7. HTTP, you're familiar with that. That runs at layer 7. File transfer protocol runs at layer 7 as well. We'll take a look at FTP and its cousin trivial file transfer protocol, TFTP, later in the course, but they require input. They run at layer 7. And finally, a little something called the Simple Network Management Protocol, SNMP, runs at layer 7. That's a protocol that allows us to gather information for network analysis, particularly in Cisco Works, which is a GUI interface application that Cisco makes that makes our network management a lot simpler. The presentation layer, very simple. Talk about the name is the recipe. That's what it does. It answers one simple question: how should this data be presented? And again, in addition to properly formatting the data, I want to remind you that encryption occurs at the presentation layer of the OSI model. If you have ever opened a file in any kind of word processing application and you get, let's say it's a 3-page document, and you open it up and you get about 600 pages of what looks like garbage, it's unrecognizable characters, that's a presentation layer issue. There has been no agreement on how the data is going to be presented. If you create something in Adobe, especially older versions, and then you try to open it with Word later, if you've ever done that, you're nodding your head right now because I have. It just spills out literally hundreds of pages of junk that you can't read. That's a presentation layer issue because there's no agreement on how the data is to be presented. Really, we've got 4 primary tasks that the presentation layer is concerned with: compatibility with the OS, proper encapsulation of data for network transmission, the data formatting, whether it's ASCII or binary, and data encryption, compression, and translation. And you've seen some of these file types used at the presentation layer, especially JPEG, MPEG, MIDI, TIFF. You know, if you've worked with Microsoft Visio, you're familiar with TIFF files. Any file type that has something to do with how data is presented is being used at the presentation layer. You know, someone's got to be in charge of all this, and in the OSI model, it's the session layer. Layer 5, the session layer, is the manager, if you will, of the two-way communication between our remote hosts. This is the layer that handles the creation, the maintenance, and the teardown of the communication channel between those two hosts. And the overall communication itself, it will not surprise you to learn, is a session. Now, some sessions are very short. You know, one host is going to send another a unidirectional message. There's going to be no reply. And other sessions, of course, will be of longer duration. But it's the session layer that actually manages the communication. Now, the transport layer, the purpose here is to establish a logical end-to-end connection between two systems to segment the data, and segment and transport layer go together. Very important. To segment that data received from the upper layers of the OSI model, and to make sure that the data gets to the destination in the correct order and free of errors. There's a lot going on there, isn't there? I mean, that's a lot. And we're going to talk a lot about this layer in this particular video as it relates to TCP and UDP. We've got two methods for transporting data at the transport layer. Connection-oriented, and that phrase should immediately tell you TCP, and you will see why. And connectionless, which refers to UDP. And again, we're going to take a much more detailed look at these two protocols later in this particular section. Now, the network layer, it's at layer 3 of the OSI model, the network layer, that you and I as network admins, we begin to have a great deal of interaction with the network. Probably the greatest amount of interaction, just depends on your job role. The Internet Protocol, IP, runs at this layer, and since routers operate here at L3, this layer is also often called the routing layer. And the IP addresses that we use here, they're called IP addresses, layer 3 addresses, routing addresses. If you think that that's a lot of names for one thing, you haven't seen anything yet. That's network, and we like to have more than one name for the same thing. Yeah, in a nutshell, routing is a two-question process. What valid paths exist from the local router to a given destination? And what is the best path or the optimal path to take to get there? This sounds so simple, right? How can this be complicated? Listen to that. That's as easy as it gets. Well, that's the concept, but as you and I both know, when it comes to networking or anything else, the concept can look simple, and when we start adding things on, it gets a little more complex. But really, routing is two questions. What paths do we have to get where we want to go, and which one is the best path to take there? And a lot more on this layer, as you would expect, to come in this course. Now, the data link layer, this is where our switches run, and we're going to spend a great deal amount of time on switches later in this course. Those operate at layer 2. Wireless access points, WAPs, also operate at this layer, and we will talk more about wireless access points in the wireless section. Devices that you may be using right now to access the internet, cable modems and DSL modems, they're considered layer 2 devices as well. We have 4 major specifications that run here, and some of these you've probably heard of. Ethernet, High Data Link Control, HDLC, PPP, the point-to-point protocol, and frame relay. Ethernet we're going to talk quite a bit about in its own little section, and then those other 3 specifications we'll talk about in our wide area network portion of the course. Very important distinction here. And this isn't just for the data link layer. This is for every layer. This is for everything you ever do. There is a big difference between error detection and error recovery. Error detection is finding an error. Error recovery means actually doing something about it. And they're not always going to happen at the same time. At layer 2, we have error detection through something called the frame check sequence. The FCS allows the recipient of the data at layer 2 to verify the integrity of the data to make sure it was not corrupted during transmission. But the recipient can't do anything about that. So there's error detection, but not error recovery at layer 2 of the OSI model. Now, a few minutes ago, I mentioned that we really like to have more than one name for things in networking, and nowhere is that more true than at layer 2. Because while the data link layer is generally referred to as layer 2, MAC addresses are also called layer 2 addresses, Ethernet addresses, physical addresses, and burned-in addresses. I'm probably leaving one out. I will not leave one out when we talk about these addresses later in the course. But again, we've got several names for those, and I will make sure that you know those when we get to that part of the course. Hardware address, that was it. And this is why I wanted to bring this up right now, is that there is another name for the MAC address. It's a little misleading. MAC addresses are sometimes also called hardware addresses and physical addresses. And that's because a MAC address is actually physically burned into a piece of hardware, the network interface card, which leads us to another name for this address, a burned-in address, BIA. Trust me, I will list all these for you in another section side by side. I know it can get a little confusing. Now, the misleading part here is that while we call that a physical address, it does not run at the physical layer of the OSI model. It's a data link layer address. A physical address is used to deliver a frame, but not a physical layer address. Don't blame me, I didn't come up with it. I didn't come up with all those names, I promise you. Now, switches operate at layer 2 of the OSI model, as do bridges. Now, I'm going to step away from the CCENT theory here for just a moment because I want you to know a little real-world stuff here. And I do introduce that into the course as often as I can because it's not just about getting certified, it's about knowing what's going on in the field. There is such a thing as a layer 3 switch. Now, on your exam, switches run at layer 2, routers run at layer 3, and the two never meet. But there are such things as layer 3 switches, and they're getting more and more popular because it's a single device that can do the job of a router and a switch. And they are fantastic to work with. Now, layer 3 switches exist, but when they're operating at layer 3, they are not switching or bridging, they are routing. And again, you don't need to know about layer 3 switches for the CCENT exam. You should probably just blot it out of your memory. But I do want to mention that because you can go in a workplace tomorrow interviewing for a job, and if they talk about layer 3 switches, I want you to know that they're not making that up. There are devices out there that can switch and route at the same time, and they're called layer 3 switches. When things get a little complicated in networking, I like to remind myself that it's all ones and zeros. No matter how complex your network gets, it's all got to be translated, knocked down into ones and zeros. The data the end users are creating, it's got to be put into ones and zeros. And once that's done, it's the physical layer that handles the actual data being transmitted. Anything to do with a physical cable or the standards that are in use, whether that's the pins, the connectors, what the voltage is, what the current is, that's all running at the physical layer.